Today we're going to talk about inequalities in one triangle, section 5.5. So we're going to talk about some more of the properties of a triangle and what that can mean to kind of help simplify some problems up. So inequalities in one triangle, section 5.5. Angles and sides in triangles. Okay, we're going to talk about this theorem today. It states, if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. Well, let's think about that here in context. Let's say I take an angle like this right here. Okay? Does everybody agree that angle is kind of small? Okay? So would you agree like the black line is kind of small? Well, let's say I make the angle larger. Is my side... Oh, there's a bad one. Is the side that's opposite going to be longer then? Yeah, that's what this is saying here. Okay? If in a triangle, let's say for instance here, x is the largest angle. Well, if x is the largest angle, that's going to be opposite of the largest side. Okay? I can use the same thing here. Where'd my meter stick go? So again, small angle, opposite small side. Alright, so first problems here, let's look at them. So number one, I want to write the angles in order from smallest to largest. Now remember, the last theorem we just said, the smallest angle is opposite the smallest side. Largest angle is opposite the largest side. So which one is my smallest side? I'm given all three sides. Which one's the smallest side? ST here is the smallest side. So what is opposite of ST?
V.
So my smallest angle is going to be?
V.
Angle V.
Yeah.
Joe, is that dark enough blue for you? Is that good?
That was a different shade of blue.
Awesome. Thanks, Joe.
Just like
Next one here. What's my second smallest side going to be? 27. What's opposite of 27? So then I have angle S, quite N. And the last one, which is my longest side? 36, which is opposite my largest angle, which is angle T. So I can put them in order from least to greatest based on their angles and side measures. Now number two is flipped. Number two, it gives me the angle measures. And I want to list the sides in order from shortest to longest. So which is the smallest angle, Chris?
H.
H is 50, so what's my longest or shortest side then?
KJ.
So I have KJ. Next, which is my second smallest angle, Spence? 53. What's opposite 53? So I would say HK. And lastly, what's my third or my largest angle, Audrey? K. And what's opposite of K? HJ. Nice job. So again, small angle, opposite small side, large angle, opposite large side. Take a couple seconds, try numbers 3 and 4 on your own. All right, number 3. I want to write the angles of triangle DEF in order from smallest to largest. Anderson, what do you got?
FDE.
So I want angle F, followed by angle D, and then followed by angle E. Nice job. 4. It says write the sides of triangle GHI in order from shortest to largest. Well, here's the thing. I only have 2 of the angles. How would I find the third angle, Brock?
You'd have the 2 on the bottom, you'd add them together, and then you'd find that you can take that.
Yep, so I want to subtract that from 180, right? And we do that, you get angle I is what then, Brock?
60.
60. So now that I know it's 60, Brock, what are the smallest, shortest to longest sides? IH, followed by GH, and then followed by, what was it, GI? Nice job. There it is.
Yep.
Next thing we're talking about here, using some of the same information here, gentlemen. The triangle inequality theorem. Now this is kind of important to recognize, okay? Because a lot of times, like when we go to take standardized tests, you can rule out a lot of wrong answers just knowing this part of information right here, okay? And it says this: the sum of any 2 side lengths of a triangle is greater than the third side length, okay? Oops, hit the wrong button. So what that means here is the two sides of a triangle have to be greater than the third side. So I'll give you a demonstration here. So again, if you recognize here, it'd be like saying if I took a triangle like this, another triangle like this, it doesn't add up. The third side has to be larger. So let's be like 2, 2, and let's say like this was 6. Okay, that does not give me a triangle. But if this were 4, 3, and 5, or let's say 6 there, that gives me a triangle now. So as I look here, I want to tell whether a triangle can have sides with the given lengths. So number 5 is 3, 5, and 8.
No.
So as I look at this here, really I'm going to look at the two smaller sides. Are the two smaller sides added up bigger than the third side? So is 3 plus 5 greater than 8? No. 3 plus 5 is not greater than 8, so that's a no. 6, 11, 15, 21, would that give me a triangle?
Yes.
Yes, it would. 7, 0, 5, and 6, would that give me a triangle?
No.
Why not?
It's not greater than 6.
Well, let's put it this way. Some of you are like, well, 0 plus 5 is not greater than 6. Let's stop even before we get that.
You can't have a 0.
Can I have a 0 side length?
No.
If the side length is 0, does the side exist?
No.
Doesn't even work. Okay, that's no.
Much like Squidward.
8, 12, 12, and 23, would that give me a triangle?
Yes.
Yes, it would. Okay, let's say I gave you a problem like this. Let's say if I gave you -2, 8, and 9. Would that give me a triangle? I can't have a negative distance if it's a triangle. Yeah, this right here, that tells me right away it's got to be no. Okay, you can't have a side length of 0 and can't have a negative side length. Same thing. Take a second to try these 4 on your own.
No.
All right, so let's look at number 9 here. Let's look at these.
Anything but quarters is completely useless. Yeah.
Tell whether a triangle can have the given lengths. Number 9, Luis, 8, 8, 16, yes or no? He says no, I agree. Nice job, Luis. Number 10, 0.5, 0.7, 0.3.
Yes.
Katie, yes or no? Yes. Nice job. 11, 10.5, 4, and 14. Quinn? Number 11, yes or no? Yes, nice job. And 12, Becca. It gives me 3x plus 2, 4x, 2x, and it says when x equals 4. What do you do with that 4? I plug it in for x. And when I do that, what are my side lengths? Huh? 16, 14, and what? And 8. So is that a triangle, yes or no, Becca? Huh? Yes, it is. Nice job. And there's your assignment today.